Hello there and welcome. In the previous lesson, we installed Visual Studio Code, so now we have a place to write our code. But before we start learning C#, we want to create our initial project. This project will serve us this entire course. So we're going to create a new folder. I'm going to do it on the desktop, and I'm going to name it C# tutorial. We need to create a folder so Visual Studio Code will recognize it as a program. And then we need to create some special files in it so it will basically be able to run it and compile it and do different things. Right now it's going to be empty, but in order to create these special files, we're going to open Visual Studio Code. And we need to find the terminal. So we can use the terminal that comes with Windows, but Visual Studio Code also has its own built-in terminal. You can click over here at the top, Terminal, New Terminal. And at this point, we are in this folder. So this is C users and the name of my user. But we need to find our folder, which is located on the desktop. Now you can navigate and find the location from the command line, or you can simply open this folder and click over here at the top, and it's going to show you the full path. So you can simply right click, copy, and over here type cd. So this is a command to change the directory, and right click, and it's going to paste this full path. Press enter, and now we are working inside of this folder. And now we can run a command that will generate these files and basically create a new program. And the command is .NET new console. You press enter, and it's going to take about a second. If at this point you get some problems, it means that you did not install the extensions that we talked about in the previous episode. All the extensions that are related to .NET and C#. So just make sure that they are installed, and then you're going to be able to run this command and basically create a new project. Now, if we go to this folder, we can find these files that were generated, and we have this main program file, and you can see that it has this CS extension because it's a C# file. So we are going to basically use this folder as the main project folder for this course, okay? So now we want to basically open this folder and use it inside Visual Studio Code. Now to do this, all we need to do is close the terminal and open folder over here. Then we simply navigate to the location of our folder and we select the folder and open it. And now we can see it on the side over here. We have this program CS file. We have some other files as well. It will automatically generate a few other files as soon as we open it, but this is the main file that we want to focus on. So we can click on it and we can see a very simple program. It's just a command that prints hello world to the console, okay? And another thing that I want to check for confirming that everything is working is clicking over here to basically run this program. And this is what we talked about in the previous episode, compilation. We can write some code, click over here, the IDE will compile the code and basically execute it. So we click over here. It will take some time, especially if it's the first time you use it. But then you're going to see hello world. And it means that this program, this code, has been executed successfully, okay? So just make sure that everything is working and we can continue with the lesson. There are many programming languages out there, but they're all a bit different. Many programming languages, including C#, follow a style called Object-Oriented Programming, or OOP. This approach is used in software development to create reusable, organized, and easy to manage code. And in this lesson, we're going to take a closer look on how C# uses OOP and why it's such an important part of the language. So what is object-oriented programming? Think about the real world. Everything around you, your phone, your chair, a car, everything is an object. And each object has properties, things that describe them, and also actions, things that they can do. For example, a car has properties like a color, speed, brand, and actions, for example, drive, stop, or honk. And the same way, a dog has properties, a name, a breed, age, and also actions, bark, run, and eat. The same way in C# or in any object-oriented programming language. We have objects. Everything is made out of objects. Now the question is, how do we create these objects? To create an object, we need something called a class. So a class is a blueprint. It's a plan. Imagine you're designing a new type of car, but before actually constructing the car, you need to have some kind of plan, you need to have some kind of blueprint that will specify all the different properties and all the different actions that this car will be able to do. And this plan is a class. Once you build the real car, then it will be an object. So let's see an example. Before we can actually create a car, right? Obviously, it will not allow us because it doesn't even know what is a car. We need to create this car blueprint. For this, we're going to create a separate file for the class. And usually also in Unity, each class should be placed in a separate file. This is just good practice. It's easier to manage all the different classes this way. You don't want to put many classes in the same file unless they're really related. Even then, you should always keep them in separate files. So we're going to create a new file. You can click over here or right click. I'm going to click over here and I'm going to name it car.cs because it's a C# script. Press enter and we're going to have a new file over here so you can see these tabs. Now at this point this is not going to recognize it, but we are going to create a blueprint, a class for a car. So let's say class car, and we need these brackets to basically contain all the information. So we have a class named car, and these brackets basically tell us that all the code should go inside. Now, as I told you, each object or each class has its own properties and actions. Properties can be any kind of data. So for example, we need a name, so public string name, and public string, let's say horsepower, public string max speed. So each car has its name, has horsepower, has max speed, and these basically are variables that store data. Don't worry, we're going to get to this in different lessons. We're going to learn about different types of variables, data types, access modifiers, how to actually use them. This is just an example of how a class looks like. Then we also have actions, which are basically methods inside of a class. So public void, let's say drive, and maybe also stop. We can also print something to the console if we use this method. Obviously in a real program this will actually do something, not just print information. So console write line, car has started driving, or car is driving. And here car has stopped. The important thing is that we have properties, things that describe this object or the future object, right? This is not an object, this is just a class. This is a blueprint. But once we use this blueprint to create a car object, we're going to have a car object. and we also have actions. Now you can also notice these white circles, and it basically means that this file is not saved. So we changed something, but we still did not save it. And you can simply go to File, Save, and basically it will save the file, or you can use this shortcut, Control S. And now that I'm pressing Control S, you can see that this white circle is gone, and it means that the file has been saved. If I add something else, it will show it again because this is something new that we still did not save. So I'm going to remove this, and I'm just going to save anyway, Control S, and now this is gone. We know that this class is saved. Now that we have this class, that we have this blueprint, we can go back to our program and we can see that this car is recognized. We don't have an error anymore, right? Because it knows what is a car. And we can use this car class to create an actual object. So I'm going to create a new car, and I'm going to use this equals operator, or basically it will assign a value to this thing over here. Now again, we're going to talk about all of this later on, but when we use this thing over here, it basically takes the value from the right side and assigns it into the left side. So we're creating a new car using the car blueprint, and this will basically be a new car. So we're just creating a fresh copy of a car. It will still be empty, right? It will only have these default things, but for example, over here, it doesn't have a name. It has a property for a name, but the name itself is empty, right? Also, the max speed is empty. We don't know what is the max speed. So we can add all of these things over here. We can take this new car that we created. We can say max speed will be 120. Now it's going to give us an error, and we talked about these errors that we can know about because of this IDE, right? If we write this code in a notepad, we're not going to see this error. But because it's an IDE and because we install these C# extensions, it will give us warnings about different errors. And the warning over here is because we're trying to add a number to the max speed. Now, it may sound like a logical thing to do, but if we go to the class, we can see that the max speed is actually a string. Now, again, we're going to talk about different data types later on, but something that will use numbers should be an integer. So we're going to change it into an integer. Also goes for the horsepower. It should be an integer. The name can be a string. And just for you to understand, integers are numbers and strings are pieces of text, right? So again, we're going to talk about this later on, but just know that now, because it's a number and it's an integer, we don't see this error anymore, and we can assign this value to the max speed. Now, if we want to use something else, we can say new car, and we can basically use these methods over here, these actions, and say drive. And if we run the program, it will basically execute or run this method, okay? Now we can do something interesting. We can basically take the max speed and print it as well. So car is driving at, and it will print car is driving at max speed, but the max speed will show its value. And the value is 120, right? Because we created a new car, we set the value, and now we are going to drive. And if I run this, you can see over here, car is driving at 120. So this is a very short overview, so you understand that we have actual objects, okay? Over here, this is an object, and we can use this object, we can use the properties, we can set the properties, we can use the methods, we can do many more advanced things with objects, but to create an object, we are using a class, which is a blueprint, and over here we have this class. Okay, and the class contains properties and it contains actions, or as we call them, methods. And I keep mentioning Unity, and that's just because most of the viewers on my channel are coming from a Unity background or want to come into Unity. So I'm giving you these examples, but again, C# is not only used for Unity, it's used for many other things. So you can still follow this tutorial, this course, without actually using it for Unity. It will still apply, all the knowledge will still be relevant, okay? So in Unity, for example, we have game objects, and game objects are basically objects. And even things like transform, which is a special object in Unity that stores position and rotation and scale of an object, even the transform is an object. So objects can contain other objects, right? For example, if we have a car, we may need to have information about, let's say, owners. So we can have a public owner, car owner, and this gave me something else just because we still don't have an owner, but we can see this error. But if I create a new file, owner, and we can go to the car class, we can basically copy all of this. So just select everything until the last bracket. Never forget the last bracket because sometimes you're going to miss it and the program is not going to work. So now that everything is selected, simply copy and paste it inside of the owner. And now we have this code over here, but we're going to get some errors because this is no longer a car. So just rename it to owner. And of course, the owner will have different properties and different methods. For example, it won't have stop or drive, right? It doesn't make any sense. It will also not have a max speed or horsepower, but the owner can have a name. We can also say public int age, right? Maybe the owner has an age and we want to know if he's a new driver or maybe older driver. So this is relevant for the owner. We want to know has insurance, right? We want to know if it has insurance. This should be a bool. So this is another data type. And now that we have all of this, of course, we don't need car owner because the owner itself should not have this, but we have another class that is named owner, and now inside the car class, we have this owner class. So an object can contain other objects, and this owner object can even contain other objects. And that's the beauty about object-oriented programming. Everything is an object. Even this entire program is an object. And then this program contains other objects, and these objects can contain other objects, and these objects can interact. For example, we want to know what is the name of the owner, so we can say console write line, and then we're going to use new car owner name. And we can run this program and it will print us the name of the owner. Obviously, at this point, it's going to be empty because we still did not assign any name for the owner. But we can use this object, car owner name, and say that the name of the owner is Mike. And then when we print this, it's going to show us the name of the owner. Obviously, we should also use some kind of car owner and if we run this, now you can see that we got an error, and you're going to experience a lot of these errors as you learn about C#. This basically tells us that we have a null reference exception, and this is the most common exception. It means that something is missing. And it tells us object reference not set to an instance of an object. And this basically means that we have a problem with one of our objects, And the problem is that the program cannot find this object. We also get information about the exact line, right? Line 7, you can see it over here. And as we discussed, this is the good thing about IDEs. It gives us a lot of information about different errors. So we have a problem over here. And the problem is that we try to assign this mic name to the car owner, but if we go into the car itself, the owner is an object, and we did not create this object, right? We did create a new car, but we never created a new owner. So when we try to assign this name to the owner and then also use it, the program says, well, I don't know. Who are you talking about? I mean, this is nice and all, but you never created a new owner. So this is why we get this null reference. And always remember, null reference means it cannot find a reference or a connection to the actual object. So to do this, we need to create a new owner. So owner, new owner. Obviously, you can name it something else. Cars owner, new owner. But then you also need to assign this to be the owner of the car. Otherwise, it's just an owner. So you need to say new car. Car owner is. So we basically take this new owner and we set it to be the car owner, and then we can also set the name, and then we can print it, and now everything is going to work. And we can see cars driving at 120, but also car owner is Mike. And again, if this is overwhelming, it's fine. This is just the first lesson, and this is just so you understand what are objects and classes, and that this is the foundation of OOP, and this is actually the foundation of C#, right? Because everything is an object, and you need to understand how these objects interact with one another, that they contain properties and methods, and we can use these methods and properties in the actual program, and that these classes are just ideas, right? These are not real objects. These are just ideas that we can then use to create objects, and these objects are inside of the actual program. And again, it will take time until you actually understand that every object should be created first, right? It should be initialized, otherwise it's going to be empty, and this is why we got this error over here. Before we end this lesson, I also need to mention that OOP is built upon 4 main pillars, and these are just concepts that are possible inside of every OOP language. Now, I don't want to overwhelm you with these complicated words, but it's just something that you need to know that exist, and later as we progress through this course, we're going to touch each and every one of them, and you're going to understand what they mean, because at this point it will just be pointless to try to understand them. It will be very complicated for you to understand the logic, although they're rather simple. It's just a way objects can interact with each other. It's a way we can make our code work better by using different classes and different objects. So when we reach these specific lessons, I'm going to mention them, and eventually you're going to understand what each and every one of them means. But I just don't want to overload you with this information at this point early on, okay? So let's just summarize everything that we have learned. Everything in C# is an object because C# is an object-oriented programming language. Objects have properties, which is data, and actions, methods, things that they do. Objects are created using blueprints called classes. A class is just an idea or a blueprint, and it's not a real instance of an object that we can use. An object, on the other hand, is what we create and actually use in our program. Also, OOP contains 4 main pillars that we're going to understand later on in this course. So thank you for watching, and I'll see you in the next lesson.